All right, so we're still waiting on a few more people, so I'll get started in a little bit. But right now, what I want you working on are just these two problems that you should see up on your screen. Yesterday, we started talking about how we can find limits algebraically or analytically. We know there's like the flow chart. If you plug it in and get a real number, you're done. If you plug it in and get a number over 0, you're done. The issue is when you get 0 over 0, which, surprise, you're going to get 0 over 0 for these two. But we looked at different methods. We know that after doing algebra, we have like factor and cancel, we have rationalize, and then we have other algebra. We only really looked at factor and cancel and rationalizing yesterday. Today we're going to start looking at some of the other algebra. But before we do that, I do want to go ahead and review these. So go ahead and take a moment to try those for me. And we will go over them in a second. And as you're working, if you want to ask a question, feel free to unmute your mic until we start going over it. And again, I know I didn't show it, but again, we always want to make sure we try direct substitution first in our head. 4 cubed minus 64 is 0, and then of course 4 minus 4 is also 0. Since we have 0 over 0, we do want to find something else to do. Looking at this one, we would want to try to factor it. Since we have polynomials, like rationalization is really only used when you have the square roots. Factoring, this is the difference of 2 cubes. If you need to be reminded of that factoring pattern, if you have a cubed or b cubed, the factoring pattern, we have a squared, ab, b squared, and then it's the SOAP is how often people remember it, where we have same sign, opposite sign, always positive, or same sign, opposite sign, always positive. So factoring this one out, you should have gotten x and 4, x, 4x, and 16. Same sign, opposite sign, always positive. The goal is right now you have 0 over 0. You want to cancel something out. You basically want to cancel out the 0 over 0, the hole in the graph. So x minus 4 does cancel, and we can go ahead and substitute. I left off my squared on that x, but plugging in the 4, we do have 4 squared plus 4 times 4 plus 16. And again, I am perfectly fine if you leave your answer like that, but you can also add it all together. Looking at this second one, you will also get 0 over 0 when you do your direct substitution. When you see a square root, that's your big clue that you want to rationalize the problem. When you rationalize, you multiply by the conjugate, which is where you change the sign in the middle, making sure you multiply by that on the top and the bottom. Remember, you want to make sure you write the word limit until you actually take the limit of the problem. So I have the limit as x goes to 1. Some other good tricks also, the denominator did not originally have a square root, so I'm not going to multiply that out, because again, the goal is we want something to cancel out. And then in the numerator, I'm going to go ahead and FOIL this together. So I have first times first is 3 times 3, which is 9. The outer is a 3 square root of 2x plus 7. The inner term is going to end up giving you a negative 3 square root of 2x plus 7. So we know that those would end up canceling out. And then we have last times last. A negative and a positive makes a negative. And then the square root of 2x plus 7 times itself would just give you 2x plus 7. Please be careful. I did put that 2x plus 7 in parentheses because we are going to have to distribute that negative across. So simplifying what I have so far, I have the limit as x goes to 1. 9 minus a 7 is 2 minus 2x. And then I have x minus 1 times this 3 plus 2x plus 7. Could go and try to plug in 1, but right now nothing is really canceling. That numerator, we're still getting 0, and that first factor in the denominator is going to be 0, so we do need to kind of keep going. Any suggestions from any of y'all of what I can do next so that I can finally evaluate the limit?
Pull out a 2 from the numerator.
So you could pull out a 2. I'm going to go up kind of here to see what that happens. If I just pull out a 2, I end up with 2 times 1 minus x, which is not going to exactly cancel with x minus 1. So what might I want to pull out instead so I actually have a factor that will cancel?
Negative 2.
Negative 2. So we kind of have options here. So now if we pull out the negative 2 instead, you'll see that that will give us a negative 1 plus x, which is, of course, a negative 2 of x minus 1. So being able to flip factors around is a pretty important skill. So like by factoring out a negative. So when I do factor out a negative, I have the limit as x goes to 1. I pulled out negative 2, x minus 1 over all of this. Again, the goal is really for any of this. Eventually, you should be able to cancel things because you basically need to cancel out the 0 over 0. And then you can go ahead and do your direct substitution. So I have a negative 2 in the numerator, and the denominator 3 plus the square root. 2 times 1 plus 7 is 9. I'm fine with an answer that looks like that. Most of you will probably say that's negative 2 over 6 and negative 1/3. So that's kind of what we were looking at yesterday. We have factoring as a way to evaluate a limit when we get the indeterminate case 0 over 0 or rationalizing. Any questions on those two?
When can you stop writing the lim?
So if it's like multiple choice, it doesn't matter because you're just looking for the answer. But on the AP exam, if you don't write the limit, they're going to take off a point for what they call a linkage error. And it's kind of like if I just had, I'm going to write it in like purple up at the top. Like if you had the square root of 4 and you just started writing the number 4 over and over again, clearly those aren't the same things. Like the square root is the actual operation you need, and it's kind of the same way for limits. That limit in the front is an actual operation. So you can't just drop it off until, like what I have boxed in, once you finally take the limit, then you no longer have to write it again. But it's just, and they don't always take points off, but sometimes on the rubric, and we'll of course talk more about the AP exam later, but they usually will take a point off because they're calling it a linkage error.
Oh,
Mr. Brown?
Yes.
Just a question. Where would that hole be for?
The hole would be, good question, for the second one or the first one?
Either or. I just want to see.
So the hole would be at the x coordinate is where the limit is approaching, and then the y coordinate is the actual answer to the limit. So I simplified the second one, so I'll talk about that one a little bit better. The hole for that one would literally be at the x coordinate of 1 and the y coordinate of negative 1/3.
Okay. Thank you.
Because basically what we're finding, if you kind of think back to what a limit means, the left and the right hand side are matching up. We don't have the graph in front of us, but basically by canceling out that hole, we can figure out the value that the left hand side and the right hand side are going towards. Any other questions? All right. Now we're just going to look at a lot of ones that just have different types of algebra. Here's one that has kind of like a plus h. We'll see these a lot in calculus. Some of you might know actually what that means, but I care more about can we just do the algebra to solve it right now. If you remember from the spring, this statement right here, the f of x plus h minus f of x over h is called the difference quotient. Again, I'm not too concerned about like what it means right now. I just want to make sure that you can find the limit. Some things I do want to point out with this one that's a little bit different from some of the other ones we've done. This one has h approaching 0 instead of x approaching 0. So the variable that is changing in this one is going to be the h. And x is going to kind of act in some ways like a constant. Since it's not changing, it doesn't have the limit for it. So the first thing you want to do before you even can do the problem is you need to figure out what this limit is going to look like. Like obviously there's not much to have to do for the over h. We do need to find something for what is f of x plus h and then minus the f of x. So when we see f of x plus h, what is that literally telling you to do? Or I'll ask it this way. If you saw f of 2, what would f of 2 mean?
You just plug it in.
Plug in 2 for x. So if I say what is f of x plus h, what are you plugging in for x?
X squared.
X plus h.
X plus h. So if we're looking at it right here, I'm going to kind of highlight it. I'm going to do it in green. When I see f of x plus h, that tells you anytime you see an x in the problem, you're going to replace it with an x plus h. So the original problem was x squared, but instead of saying x squared, we're going to say x plus h squared. You could leave it like that. I know eventually you want things to cancel out. So I'm going to go ahead and FOIL that. Make sure you don't just distribute that squared. But FOILing it will become x squared plus 2xh plus h squared. So plugging that into my limit, I first have this f of x plus h. Well, what was f of x plus h? It was x squared plus 2xh plus h squared. And from that, we want to subtract f of x. Well, what was f of x? F of x was just x squared. So looking at this limit, we are plugging in the limit when h goes to 0. So make sure we plug in 0 for h and not x. But plugging in 0 for h right now, you can kind of see like there's an h in the bottom, so you're over 0, and then that numerator also works out to be 0. So we do want to find some ways to simplify it first. What's one way we can see to simplify this limit expression?
Minus the x squared and
The x squared, yep, they cancel out. So then I have 2xh plus h squared all over h. All right, h is going to 0. Oh no, still have 0 over 0. What can I do next?
take out an h from the top and then divide by h.
So I can take out the h from the top. So I have 2x plus h all over h. Those h's now cancel, so we should have solved the issue of getting a 0 over 0. Again, remember that it is h that is going to 0. So when you plug in 0 for h, what are you going to be left with?
2x.
2x. So this is kind of a unique limit, like where the answer is not just a number, it's actually an algebraic expression. For those of you who might be like in AP Physics or just know, like, yes, we did just find the derivative, but for everyone else, we'll just say right now, that is how we will find the limit for that problem. Questions on that? All right, let's try another more algebra one. Instead of me just jumping into it, I'm going to give you a chance to try it on your own. Go ahead and see if you can find that limit for me. Of course, always check direct substitution, but you can probably assume you're going to get 0 over 0, or there wouldn't be much work to do. Does anyone have any suggestions of what they tried to do first to solve this limit?
I tried to get a common denominator between 1 over x plus 3 and negative 1/3.
And what is that common denominator?
3x plus 3.
Yep. So if I want to get the common denominator, we can see the common denominator is, let me switch colors, 3 times x plus 3. So you could do it, I think that was TJ who said it, but we could do it where we could just get the common denominator in the numerator and then like simplify that and then divide fractions. I know we all love a good shortcut, so I'm going to kind of take what TJ suggested and expand it. So 3 times x plus 3 is the common denominator. I'm going to multiply by that common denominator on the top of this fraction and on the bottom of the fraction. So I do want to make sure I do it to both of them since I can only really multiply by 1. And then you'll kind of notice when I go to distribute this across the numerator, we no longer have like those extra denominators. So 1 over x plus 3 times x plus 3 is just going to leave us a 3. Then I have minus 1/3, and the 3 will cancel out, and you're just left with the x plus 3. And then in the denominator, we have an x, we have a 3, and then we have an x plus 3. You could try plugging in 0 now, but we still have 0 over 0 because we haven't really canceled anything out. We haven't really simplified it as far as we need to. Most of us, I think we can see we need to distribute that negative across. So I have the limits as x goes to 0, 3 minus x minus 3. And then we can kind of see things start canceling out nicely. So like the 3 and the minus 3 cancel. And so I just have a negative x over the 3 x times x plus 3. So now the x's can cancel. I'm going to go ahead and write down what we have left over. I still have a negative up in the numerator and a 3 over x plus 3. We're happy now because we can go ahead and do our direct substitution. X is going to 0, so the limit is going to be negative 1 over 3 times 3, or you can just write that as negative 1/9. So again, there is a hole in this graph, and the hole happens to be at 0, negative 1/9. And again, that's not the only way you can do it. As long as you do proper algebra and as long as you cancel things out eventually, then you should get to the same answer. Any questions or concerns about that problem?
Mr. Brown,
Yes.
for the last problem, when you canceled out the h's, what happens? Is that a graph thing, or does anything happen to?
So this one's hard to talk about because we don't, like, that h represents something right now. And so right now I'm going to try to be vague and just say just trust the limit process for right now.
Okay.
We will learn what that means next week, or actually in 2 weeks.
Got it.
So I'm going to leave it vague for now. Any other questions or concerns? All right. This one I chose just because I know we probably haven't dealt with factorials, or maybe you haven't dealt with factorials in a while. On the AP exam has both a multiple choice section and a free response section. A lot of the limits questions are on the multiple choice section, and of the multiple choice, there's a calculator and no calculator, and most of the limits are on the no calculator. So I do just want to review things like just making sure we know how to simplify things like quickly. For our benefit, I know when you're at home right now, you have like a calculator probably, but that won't always be the case. So remember when you have a factorial, like if I just kind of go off to the side, a factorial basically means like you start at that number. So if I had 6 factorial, that would be equal to 6, and then you multiply all the way down to 1. So 6 times 5 times 4 times 3 times 2 times 1. There are some special cases, like obviously 1 factorial is just equal to 1. We don't do factorials of negative numbers, but we can do a factorial for 0, and 0 factorial is defined as 1. So that is kind of something you might want to make a note of, is that 0 factorial is defined as being equal to 1. Kind of like saying anything to the 0th power is 1. So if we're simplifying these by hand, we know obviously we just want to try and go ahead and do direct substitution first. So in this first one, the limit as x is going to 5, we end up with 5 factorial over 12. And so that is the answer. Like if this was a free response question, you can leave it like this, but that's definitely not going to be an answer for a multiple choice one. So I think the easiest way to simplify it, especially if you don't have a calculator, is to go ahead and expand it. And instead of multiplying together 5 times 4 times 3 times 2 times 1, which you could do, you're more likely to make a mistake. I would go ahead and try to simplify it first. For example, I might say, all right, 2 goes into 12 6 times. 3 can go into 6 2 times. And then for the last one, 2 goes into 4 2 times. So you can see that this limit, we just end up with 5 times 2 times 1, giving us the simplified answer of 10. And I probably could have even done that faster just by canceling out the 4 and the 3 with the 12. Go ahead and try that second one on your own for me. And so we have 5 factorial over 4 factorial. So like the long way, you could write 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1, and kind of clearly see that 4 to the 1 is going to cancel with the 4 to the 1, just leaving you with 5. A shorter way to write it is 4 is contained within 5. So I could just split up the 5 factorial as 5 times 4 factorial and still cancel the same way. Either way, you are going to get to the answer of 5. So that's where I'm going to say it again. Sorry.
If it was like 20, are you just allowed to do like 20 factorial over 4 factorial, make it 5 factorial?
Say your example again.
Like if you had 20 factorial over 4 factorial, can you just make it 5 factorial?
If I had 20 factorial over 4 factorial, you would still have to think like this is going to be like 20 times 19 times 18, and you would just stop at the 4 factorial over the 4 factorial. So that one's still going to be a really massive number.
Oh.
So you can't break down the 20 as like 4 times 5. To do one that might be a little bit easier to see, if I had 6 factorial over the 4 factorial, I would rewrite that. It's going to be 6 times 5 times stop at the 4, all over the 4, just to give me 6 times 5 or 30.
Do you have to like keep rewriting like limit for each like step like you did in the other?
On this one, I stopped writing limit as soon as you can stop writing limit as soon as you plug in the number.
Okay.
So like in this one, I could stop immediately because I could directly plug in the 5. Whereas in the previous one, I had to keep writing the limit until this very last step because I did not plug in 0 for x until the very last step. Any other questions about anything I've done today? All right, so that's where I'm going to stop class today. There are some things I want to say because I did change the calendar a little bit. So let me get situated. So the first thing I want to say, like I posted it under the general tab in Teams, so you can go back and review it, but please, please, please turn in homework 0 if you haven't already. It is due at 2 p.m. Also the homework you can be working on, so you have homework 1, which was the limits graphically, and then you have homework 2, which is going to be limits analytically. I did update the calendars. There's a short version of it, but on my webpage I did post a longer version of the calendar. And I don't know if this is showing up on your screens that well, but basically what I did, just because I'm not moving as fast as I thought I would virtually, which is fine. I'm not worried about it quite yet, but I am just moving some things around. So I took out the topic that was attached to homework 5 because I can actually cover that next unit and not have to waste a day in class for it. Your quiz was going to be on Wednesday of next week, but I pushed it back to Thursday to give me an extra day. Your test is going to be on the same day as planned. That's going to be Friday the 4th, but I took out a topic, so there will be like one less thing that we have to learn before the test on Friday. Main things though kind of coming up though, of course have your prereq stuff turned in. Next week on Monday and Tuesday we'll talk about limits intuitively. Wednesday's going to be just a complete review day. Like I'll check in at the beginning of class, but most of the period you'll just have time to work and ask me questions. The quiz will be on Thursday and it will be a live quiz. So like as soon as you get into class, I will have the quiz available for you. You will have like 30-ish minutes to work on the quiz. And then you'll have to submit it before the class period ends. So obviously the quizzes won't be as long as they were last year, but they will be comprehensive and pretty much cover what they need to. So with that being said, I am done. So if you are good to go, you can go ahead and sign out and all of that. If you want to hang back and ask any last minute questions, you're also more than happy to do that as well. But again, just make sure you have homework 0 submitted already. And then continue working on homework 1 and homework 2 until your quiz on Thursday. But that's all I've got. I will see you on Monday. And yep, that's it.
Bye, Mr. Brown.
Thank you.
See ya.